So in question number 5, the goal is to, again, kind of narrow down where on the circle our theta could be, and then figure out from there what all of these other measurements are. So the first goal is actually to just do the part that says theta equals, because that actually is the single most important answer in the entire row. Once you know where theta is, that kind of tips you off about where you can get values like cos, and then how to use our formulas from a couple of days ago to do things like tan, secant, etc. So we're going to start with number 5, letter A, and specifically, we're going to first focus on where theta could be. Just like with the other questions, they're giving you some clues about where to look. First, they're telling us to look between pi over 2 and pi. So pi over 2 is here, pi is here, which is tipping me off that I'm only looking in the second quadrant, this top left quadrant here. So those are the only possible places where I'm looking for answers. It also tips me off that I'm looking for answers in radians. Since the clue is given with pi's, that tips me again that these are radian values that they're looking for. So the other clue that they're telling us, the equation they're telling us, is sine, vertical, and root 3 over 2, the long one. So I'm looking vertically, and I'm looking at the longest possible space. So again, knowing we can only focus in that top left quadrant, I'm looking between pi over 2 and pi, so just over here, and the one number that's jumping out to me vertically is this one, because vertically, that's our root 3 over 2. That's our longest measurement in that quadrant. So 2 pi over 3 must be the spot that they're referring to in this problem. That must be our theta. So if I fill that in, 2 pi over 3, that's important now because that's giving me kind of a home base. That's giving me a spot on the circle that now I'm going to refer to answer all of the other questions in this row. So when you're doing example B as well, just keep in mind theta is the most important answer that you need to get. Once you know theta, everything else follows much more naturally. So let's finish the rest of the row then using what we know about our circle already. For example, cos. Cos is just a horizontal measurement. We know that. So if I'm looking at 2 pi over 3, the cosine is the horizontal measurement, exactly the same as we always do, and it looks like horizontally this would be the shortest measurement, and it's also to the left of the center of the circle, so this is telling me the answer to cos must be negative 1/2. Because it's short, that's always the short answer is 1/2, and it's to the left, hence the negative. Now, something helpful to keep in mind from our work a few days ago on page 17 is the idea that some of these are actually related to each other. For example, the cos formula, which I'll highlight here in a bit of a color coding kind of action here, the cos formula is intrinsically linked to the secant formula. The secant formula, as you might remember, and I actually misquoted myself, I said page 17. It was really page 18 where we wrote down some formulas for secant, cosecant, and cotangent. Those same formulas are coming back here, and it might be helpful to remember that the flip of cos is secant. And if you can remember that, and you can write it as a fancy formula, or you can just write the word flip, if that helps. But if you know that secant is the flip of cos, that kind of tips us off that we can do another one of these answers really quickly. If cos is negative 1 over 2, then secant must be the flip of that, which is negative 2 over 1. So it's almost kind of like killing two birds with one stone. Once you can get one answer, you can immediately get the other one. Now, the other kind of easy flip formula that we might remember is the cosecant formula. The cosecant formula is another flip, and cosecant is the flip of sine. So again, if you want to make a note to yourself, cosecant is the flip of sine. Now, sine wasn't one of the answers that I've already gotten, but good news, sine was actually given to us originally. Sine was already root 3 over 2. So just by using that clue, I can again use a little bit of common sense. If cosecant is just the flip of sine, then I can take this existing fraction and simply flip it over, 2 over root 3, and boom, I'm done with cosecant. So the flip formulas are super convenient because once you get one answer, you can automatically get the other one. The trickiest one for sure is going to be tan, because tan was not something I could look at by just looking at the circle. Tan had an actual proper formula that I had to use. So this is the only one for which I'll have to show a little bit of work. And I'll just give myself a little bit of scratch space by doing a fold. You can obviously use scratch paper or whatever you have. But let's take a look at tan really quickly. If you want to refer back to page 18, just so you have a formula for reference, the tan formula is sine over cos. Now, usually we have to find that information, but good news, we already have sine and cos. Those are answers that they either already gave us, like sine, or that we already found, like cos. So the only thing we'll have to do is that keep, change, flip action, which we can definitely handle. On the top of my tan formula is my sine answer, so I'm just going to reuse the number they already gave me, root 3 over 2. And on the bottom of the tan formula, we need cos, which is an answer we already have, negative 1 over 2. And just like we've done on page 18, this is going to be a keep, change, flip problem, where I'll keep the top fraction, change it to a multiplication, and flip the bottom fraction. So I'll keep root 3 over 2 as is. I'll change the problem to multiply, and I'll flip the bottom fraction to negative 2 over 1. Remember, it doesn't matter where the negative goes, as long as it's somewhere. Now, just like always, we kind of expect this to happen. There should be something that cancels out, and in this case, it's the 2's on the top and the bottom. So if I clean up what's left, I have root 3 on the top and 1 on the bottom. You don't ever have to write a 1 on the bottom, but we still have a negative left over that we can't ignore. So I'll write my answer as negative root 3. Now, since tan is negative root 3, it's kind of a weird, sort of strange answer, but that's to be expected. Oftentimes, tan answers are a little bit strange. More importantly, though, if I have the tan answer, that means now I can use it for cotan, because the important thing to remember about cotan is that cotan is the flip of tan. And once you have the tan answer, you can flip it over and you got your cotan. Now, if you're looking at this thinking, oh my gosh, wait, how do I flip something that's not a fraction? You can always go back to our work. Remember, in our work, it was technically negative root 3 over 1. If you wanted to think of that as your tan answer, the flip might be a little bit more obvious, because now the flip is going to be negative 1 over root 3. Now remember, as a disclaimer, I'm not rationalizing any of these denominators just for the sake of time and ease, but if you're checking the answer key, you probably notice that the answers are rationalized on the key. If you're going on to honors, it may be a good practice, again, to continue practicing rationalizing as that extra step. But if that doesn't really seem to be a big concern right now, then I wouldn't worry about it too much. In any case, now that you've kind of seen how to do these problems, I do recommend having some way of kind of color coding or correlating the parts that go together, so that way you don't really end up having to do 5 separate problems. Once you know where theta is, you can kind of take one measurement and then use its flip. Then take another measurement, use its flip. So that's the goal, is that you can kind of partner up these answers to make your life a little bit easier. Try letter B, but be advised that letter C is a bit of a challenge. If you're up for that challenge, it's a good one, because tan equals negative root 3 sort of seems familiar, since we just got a tan answer of negative root 3 in this problem. And that would be the hint that I'll give you, is if you're going to try a challenge question like this one, use letter A as kind of a hint or a jumping off point. But in any case, it's not the most important. I think right now, just being able to do letter B is enough. So go ahead and finish letter B, and then don't forget to check your answers. If you feel like you got this whole page and you feel like it was relatively easy for you, then don't forget to go back to that learning plan for the week, do the quick check, which is basically kind of like a little warm-up that we would have done the day after doing stuff like this in class, just to make sure the main ideas make sense. If they do, then you're certainly welcome to move on to today's homework, or you can move on to another day if you want to work ahead, figuring that a lot of this stuff is going to work just like this, where we can watch a couple of videos, get some of the basics of the packet, and then practice the rest on our own. If you have any questions, don't hesitate to email me at any point during the day, and I'll be happy to help in any way I can.